Today, we're going to take an in-depth look at the HP multi-jet fusion printing process. We're going to run through all the steps to produce the intake plenum for the CSU Formula SAE team. Hi, I'm Connor. I'm a mechanical engineer here at Avid Product Development. We're a 3D printing service bureau located in northern Colorado. Today, we're going to take an in-depth look at the HP multi-jet fusion printing process. Avid Product Development is a 3D printing service bureau. We specialize in design, prototyping, and manufacturing. On today's episode, we're going to run through the steps to make the CSU Formula SAE intake plenum. We're going to start with the printing process, then we're going to unpack that build unit. We're going to run the part through blast to remove all the extra powder. We're going to do some quick QC checks to check some critical tolerances, and then we're going to run that part through our die process. The HP Multi-Jet Fusion, otherwise known as the MJF printer, is a 3D printer made by HP. It uses similar technology to your 2D printer at home, but rather than printing onto a piece of paper, it prints onto a very thin layer of powder. Think of this as a big oven. The printer works by maintaining the powder at just a few degrees below melting temperature, and then depositing chemicals onto that layer of powder to help bring it over the melting point. Once that layer has been melted, it bonds to the layer below it and to itself, and then another layer of powder is deposited on top, and the process repeats itself. Each layer is built upon the previous layer, building your part in 3 dimensions. The unfused powder around the part being built acts as a support material, meaning that no extra support material is required to build complex geometry. Today we're going to be printing our standard gray PA12, but we can also print a light gray, almost white PA12 material. This gives us the option to dye very bright and vibrant colors. So this is a HP multi-jet fusion processing station. This is where we basically remove all of the unfused powder from the build. So after the build is done, we roll the build unit into this machine. From there, there's a vacuum hose that we'll use to basically pull up or suck up all of that unfused media. The material itself can be kind of clumpy, but it's very easy to break up. And then at that point, it is sucked up through the hose and into a barrel on the side for reuse later. Since all of the parts are in a basically cube of powder, all of that powder is acting as the support material. So as we're sucking up that material, we're basically sucking up the support material. And then that is all able to be reused. So you can see here as I'm vacuuming underneath the part, all of these overhangs are no problem. And you can see in this big part, in this big intake plenum, there's no concerns with support material inside that we have to clean out at a later date. One of the advantages of having a print with no support material is that we have a totally uniform surface finish over the entire part. There's no bumps over here or an awkwardly smooth surface over here. It looks the same across an entire part, even on complex surface geometry. Another advantage of the powder being used as the support material is that there's no cleanup afterwards for the technicians. All they do is suck up the extra powder and the parts are ready to go into further processing. This allows us to have a much better value for these parts than other technologies. After we're done unpacking the build unit surfaces will be cleaned. All the extra material, all the powder will be removed as well as possible. Now that these parts are processed, the other function of the processing station is to refill the build unit for the next build. The build unit is refilled with a mixture of the recycled material that we just sucked up and virgin material. This helps us to maintain stable mechanical properties over many builds. So now that these parts are done with the processing station, let's take them to blast for the next step. This is the Dimension PowerShot C. This is an automated piece of blasting equipment. We use this to remove all of the extra powder that I couldn't get off at the processing station. This machine works by placing your parts into the drum here. Once all the parts are in here, this drum will slowly rotate and blast nozzles on the other side will remove all of the extra powder. Let's take a look. A big part like this with a large enclosed volume probably still needs some further post-processing in the manual blast cabinet. So the automated blasting equipment is great for getting a uniform finish on the outside of the part. But on the inside here, there can still be a lot of powder trapped inside this large volume. In the manual blast cabinet, we're able to kind of focus on problem areas and use other tools like small wire brushes to really get deep into this volume and get out all of the powder through the entire part. So I can't run this with the glass open, but basically in here, I have these gloves and I have this gun on the side. This throws out air and an abrasive media, and I'm able to manually manipulate the gun into corners and crevices that otherwise wouldn't be hit on the automated equipment. Now that these parts are done with blasting, let's take them to QC and check them over. Since Avid is an ISO 9001 certified company, we have a very in-depth QC process. This is one of the QC stations. This is where I'll check the dimensional accuracy of the part versus the CAD model on the computer. Here I'm checking the internal diameter of the fuel injector port. I can note any failures on the parts and send those parts back to be reprinted. Also in the software, I can check for the next production steps. So let's go take these parts to die. So this project calls for black dye. Black dye is our most popular option and our second most economic option behind the natural gray finish that you see here. Behind me are the Gerbeau dye machines. They use a black RIT dye to dye these parts black. Black dye doesn't change the quality or the physical properties of the part in any way, but it does produce a better deliverable product. Thanks for watching today's episode. If you have any questions, please reach out in the comments below. If you'd like to get your project started, hit the link in the description below. If you're interested in 3D printing and engineering, like and subscribe, and we'll see you in the next one.